Hello everyone, welcome to my lecture series of digital electronics. Here in this lecture series we are going to discuss about different concepts and theories about digital system due to its marvelous advantages over analog system. We will discuss its advantages and will eventually take the comparison of both the systems as and when required. But for today's lecture we are going to have some basic understanding about different number system. So we do have the idea about the decimal number system because it is the most common and popular number system that is being used in our day-to-day life. But apart from this decimal number system, we do have so many number systems in our engineering field, and to discuss about the beauty and the structure of different number system, I am going to have a small discussion regarding the Greek numbers. So as you can see, I have taken a table in which the first column it is listed with some numbers from 1 to 10 and 16. In the second column I have represented the equivalent Greek numbers, and in the third column I have written the pronunciation of each Greek number. So knowingly or unknowingly we are using all this pronunciation in different concept of our study, say for example in chemistry or mathematics or physics or trigonometry, etc. Let me give you a couple of examples of this, that whenever we are using one gas which is called as CO, which is nothing but carbon monoxide. So here the name suggests the composition of the compound carbon monoxide. So mono means one, that is one atom of oxygen is bound with the atom of carbon, and this bounding will make a compound called carbon monoxide. We also use this word mono in case of electric dipole and electric monopole, which are the very well-known topic of physics. Similarly, we do use di or bi many times. So say for example I have another gas called SO2. Now this SO2 can be pronounced as sulfur dioxide. Di means two, which means the two atoms of oxygens are bound with one atom of sulfur, and it is making sulfur dioxide. Another pronunciation of number 2 is bi. We are using this pronunciation in mathematics. Say for example we do have a bisection. So having a bisection of any line means to divide that line into two parts or two lengths, and a bisection of any angle means to divide any angle into two parts. Okay, so here bi stands for two, as you can see over here. Similarly, tri, we all know that we are having a triangle. So triangle is nothing but a shape which is having three angles. So tri stands for three. Similarly, tetra, so we can have an example of CCl4, which is nothing but carbon tetrachloride. So tetra means 4, that is 4 atoms of chlorine is bound with one atom of carbon. Penta, so we can have pentagon. For 6 we are having hexagon, so the shape which is having 6 angles is known as hexagon. So all these pronunciations are very commonly used in our life, but we might have not considered them to understand the meaning of each and everything. So the number system which we are using in our day-to-day life is called decimal number system. That means our regular or well-known number system is having some relevance with number 10. But as we have discussed prior to this point, that decimal number system is not the only number system. There are many more number systems that, which are being used in engineering and technology. But 4 of them, the most popular one are binary number system, octal number system, decimal number system, and hexadecimal number system. So now you might know the reason that I have discussed this table is to make you aware about the number system is having some correlation with that particular number. So if I am talking about binary number system, that means we have some correlation with number 2. If I am talking about octal number system, that it is having some correlation with number 8. Similarly, for decimal number system, it is having a relation with number 10, and hexadecimal number system is having a relation with number 16. Now, moving further, so as per our discussion, we are going to learn about these 4 most popularly used number system. So decimal number system, which is having a correlation with 10, so we can say for decimal system the radix is 10. For binary system, due to the presence of bi in its name, we can say that the radix of binary system is 2. For octal system, due to the presence of octa, it will have the radix is 8, and hexadecimal number system is having a radix of 16. Here capital R represents the radix of that particular number system. Now our next question that comes to our mind is, what is the meaning of radix? So my friends, radix is nothing but the available number of characters. Radix of any number system is available number of characters. That means for decimal number system I am having 10 characters, and which is very obvious one: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these 10 characters are of decimal number system, and any number can be formed with the suitable combination of these 10 character. Okay, in binary number system, as we are having the radix 2, we are only having 2 characters, 0 and 1. Now it is obvious that if we want to represent a same number in decimal number system as well as in binary number system, then the length of this data will be way more high in case of binary number system, because the available character over here is just 2. However, the accuracy of data will be highest in the binary system, because the same reason the number of characters are only 2. And that is the main reason that microprocessor and microcontroller are using binary number system, because to achieve the highest level of accuracy, we must reduce the error as much as possible, and the least error in data can be introduced in binary system only. Now moving further with the octal number system, so we are having the radix 8. That means we are having 8 characters in octal number system. So these characters are 0, 1, 2, 3, 4, 5, 6, 7. So these are the 8 characters, and all the numbers can be formed with the combination of these 8 characters. And similarly, in hexadecimal number system, we are having 16 characters. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the 10 characters. Now the next character, it is 10, but we cannot use this 1 0 as my next character, because 1 0 is not a independent character, rather it is the combination of 2 already existing character of hexadecimal system. So we cannot use 10 over here or 1 0 over here. In place of 1 0 we are going to use capital A. Similarly, for the next character we cannot use 1 1, we will use B in place of 1 1. The next character 1 2 cannot be used due to it is a combination of already existing character. We will use capital C in place of 12. In place of 1 3 we are going to use D. In place of 1 4 we are going to use capital E, and in place of 1 5 or say 15th character of this hexadecimal system will be F. So these are total 16 character of hexadecimal system. As our lecture series will progresses further, we will learn how to convert any number from one number system to another number system. So for this discussion, do not worry about the conversion. This particular lecture is only the introductory session of number system. Now if I am saying that these are the characters of different number system, then we must have a formula according to which any arrangement or any combination of these characters must be defined. So that is very important formula to define any number in different number system. So the formula is very general one. So if you want to form any number, then you must start with the power of radix. So I am starting with the 0 power of radix. So R0, whatever will be the value of the 0 power of radix, we must put some coefficient, then we will add more terms if the value of that number requires or length of that number is required. We will have the increasing power of radix along with some coefficient. Again we will have increasing power of radix along with coefficient, and we can extend this formula as per our requirement or as and when the number can be satisfactorily covered in the range of the power. Now if you want to define the fractional part of any number, then we will have a point. Now the very interesting thing about this point is this point is named, we popularly known this point as decimal point, but it is called decimal point only when the number is in the decimal number system. If the number itself is in a binary number system, then this point will be called as binary point. If the number is in the octal number system, then this point will be termed as octal point. Okay, so this point is acquiring the name as per the number system. Okay, so in general we will say it is in a point. Now we will have the negative power of radix and some coefficient. Here a minus 1 is just a coefficient, it is nothing to do with the sign of this coefficient. Okay, then if required we can have the further lower power of our radix, and you can also expand it as per your requirement. So this is the general formula to form any number in any number system. Okay, now say for example if I want to make a number say 327 into decimal number system. So let us make it quite general. If I want to make 327.15, then what will be the correct selection of the combination? So first, what is the radix of decimal system? Radix is 10. So according to this formula we will write 10 raised to 0 multiplied by something. Let it be over there. Then we will have 10 raised to 1 with some coefficient a1 plus 10 raised to 2 with some coefficient. And as you can see, we will not require any higher power of radix to define 327. We are having some fraction part, so we will use a decimal point over here. We'll leave the coefficient blank and we will have 10 raised to minus 1 plus, again we will leave the coefficient blank and we will have 10 raised to minus 2. Okay, now 10 raised to 0 is nothing but 1 plus 10 raised to 1 it is 10 plus 10 raised to 2 it is 100. Decimal point, 10 raised to minus 1 is 0.1 plus 10 raised to minus 2 is 0.01. Now to make 327.15 I must put 7 over here, 2 over here, 3 over here, then 1 over here and 5 over here. Okay, now if you multiply it, then you will have 300 plus 20 plus 7 point 0.1 plus 0.05, and finally you will have 327.15. Okay, so any combination of 3, 2, 7 and 1 and 5 does not mean 327.15. Okay, so every combination of characters must follow this generalized rule to form any number. Now you might be aware that the concept of face value and place value, actually these two concepts are very fundamental, and it is covered in the lower standard of either primary schooling or secondary schooling, I think. Fine, but the concept of face value and place value comes from this formula. Okay, so the most important thing of today's lecture is the formula which governs the formation of any number in any number system, 4 different kind of number system and its characters along with its radix. So thank you very much for today. We will discuss the further thing in our next lecture. Thank you.